So the last step is just to line these up with your slot, and that can be a little bit tricky sometimes, but basically just line those up, and then it's a bit difficult with the camera. As you can see, that one's sticking out too far, so I'm just going to screw it in a bit further. Just make sure everything slides easily, and this is really important if you've got several beams that you're putting together at the same time. And then you just line it up so that you get your Allen key through, and then gauge that cap screw. And then normally you just do one at a time a little bit, just to get rid of all the play. Make sure everything's seated nicely, and then you can really line it up carefully, get everything square so there's no lip sticking out there. And then just tighten it up like that. And tighten it really tight, and there you have a standard connection. You can see the screw holes are used for access. You can see the I'll show you a better shot just now of the profile from the side view where you can see how the anti-rotation clips are sitting like that, and that's a really strong, sturdy connection. I would say the biggest limitation, if you had like a repeated impact on here, vibration, there's a tendency for this to slip over time. So in that perspective, it's not the most reliable kind of connection in a environment such as like a four-wheel drive vehicle where there's going to be a lot of pounding around. We can add brackets and additional stuff. The absolute strongest one is called the through connection, where you do a countersink hole and your bolt goes right through from the end. That needs to be done in the milling machine because there's a stepped hole like a countersunk hole, and it's obviously a more expensive connection because of the machining process. That is the ultimate. The through connection is like the strongest connection you're ever going to get, and it's impossible for it to slip without absolutely snapping off two M10 bolts, which would be a pretty extreme situation, I'm guessing.